Yes, so the title of today's presentation is the role of digital built environment in asset management. And as I said, Matt's done a fine introduction, so I won't waste any time going into talking about myself. So today on the agenda, I would like to start with a brief introduction about what we're doing at Auckland Airport and sort of an overview of what was part of awards last year. And if you would like to see further information about that, I recommend just going to the Building Smart website and viewing the awards submission. I won't go into too much detail today. Then I'll sort of highlight our team's strategy and what we're sort of following to get to the point where we are. A brief little discussion about OpenBIM, and then 10 minutes about why we've gone to dRofus and how we're starting to implement that now, and then a live demo, it's a little bit longer than 5 minutes, but we'll hopefully wrap it all up within 30 minutes. And just as a bit of a disclaimer, our dRofus implementation is only in its infancy, so anything that you see is a work in progress, so not all features are set up and working yet when I do the demo. So for those that haven't seen what we've been doing at Auckland Airport, over the past sort of 4 or 5 years, we've been working to collate a whole lot of information about our existing terminals and built assets. We own a significant, New Zealand's biggest airport, so the international terminal is about 145,000 square meters, and this has been modeled up by various companies over the years, and all sort of using different versions of software and at different timelines when different features were available. So we've got this mix of models, from design models to as-built construction models to scan to BIM models. We've just got models that have been developed from our 2D GIS information. So we've sort of been piecing it together over the years and trying to federate it and get consistency across all of our data set and build up as comprehensive view of the terminal as we possibly can. So this is a constant work in progress. We've got plenty of spaces that are missing, but we've got, architecture, structure, HVAC in places. Some areas we have electrical, we have baggage handling systems, and sort of a whole range of different information about the terminal. So as sort of the past 4 years, we've been constantly scanning more. We've been starting projects which are setting up from the start of the project to integrate into this model. And so at the end of the day, we end up with what we like to call an asset information model. So at the whole time that we're doing any design projects, we're maintaining a record of our existing model. And so here you can see what we were doing prior to COVID, where we had a number of projects. Here's a hotel, and then we had a arrivals hall project where all these models were dropping in to the right spot, being done by different project teams using slightly different versions of software, and then being exported out as IFC and being able to be dropped into our federated model. So this really enabled us to see the future as well as have a good understanding of the past. Unfortunately, a lot of these projects got put immediately on hold due to COVID, but as some of you might have seen in the media, some of these are kicking off again as we speak. So it's exciting times at the airport that we're actually doing this our largest terminal expansion project, and really trying to push the limits of what we can do with BIM in collaboration with our design partners and also contractors. So here you can see this was sort of developed design models that were being integrated into our existing building. And then the other key thing was capturing space. So in our existing buildings, we didn't have a lot of models that had spaces or rooms modeled. So this whole sort of the backbone of dRofus wasn't really there. So now it's working towards getting all these rooms. It's about 3,000 rooms mapped and modeled and imported into dRofus. So to get to that point, we sort of got to go back a few steps and look to where we came from. So already about over a decade ago, everything at the airport was paper-based, where we literally had paper documents and rolls in a storage room. This room was then discovered that it had asbestos, so the paper had to be taken out. So the next best step was to then scan the documents and digitize them in that way and store them on file servers. But it still was a very file-based way of managing information. And then around 8 years ago, GIS was introduced to the business. So this was then taking the CAD or the 2D data that we knew of, converting it to CAD, and then pushing that up to GIS and actually working towards this data-based layer of information management, where we have basically we can view most of the airport's information in 2D on a map through GIS, and sort of GIS is, I guess, one step ahead of where BIM currently is, in the sense that you can have multiple pieces of visual information, and then all the back-end data can be stored in multiple databases, and it can be easily retrieved. Whereas within the BIM world at Auckland Airport and in a lot of organizations, we're living in a file-based world. So that model I just showed you before was made up of about 100 different model files. So to then manage all that information, you've got to go into each model and sort of change the information where you need to and delete stuff, and it becomes a real bottleneck in the process. So this is where we currently are at the airport prior to dRofus, and the sort of shift to dRofus is based on this, trying to align more with the way that GIS works and having this back-end database where we can separate the model geometry from the data and have the data managed in a database. So from our perspective, dRofus is the next step in terms of moving towards the database world, and then that will then lead us into a world of linked data, which I'll go into shortly. And so a big step with information management at the airport is the fact that we have now both GIS, so Geographical Information System, which has been around, as I said, for 8 or it might even be 10 years. And we also have BIM. So now we have BIM for the last 5 years. So we have sort of these tools where we can represent basically our whole built world with points, lines, polygons, and annotation in GIS. And then in the BIM world, we're trying to represent things with objects and elements and spaces and solids and properties. So with these key sort of or fundamental representations, we can then capture basically everything that we need to capture at the airport. And a lot of our discussion is around what information should sit in GIS and what information should sit in BIM. And in some cases the data might originate in BIM as an object, but at the end of the day we just need to see it as a point in GIS. So it's really working out the data that's actually needed and working out where it can sit. But where a tool like dRofus and being able to put that data into a database then enables us to have, we could, if we haven't done it yet, but essentially we could link a point to a record in dRofus by a common ID or a line or a polygon, but at the same time have a similar representation of the same thing in the BIM world and linking to the same dRofus records. We don't have to duplicate the data between the two systems, so we can just pull from one, and that's sort of that's the thinking of moving to this data-based and linked data world. And so what we've been, as I mentioned over the past, we've been capturing data via sort of collating 2D documents, 3D BIM models that we've had from design projects, construction projects, and then scan to BIM and verifying these with point clouds and on-site survey, and also utilizing GIS apps to collect data on site that we can then feed into the model. And going forward, I can see how we could also use dRofus web to be able to get out in the field and sort of audit the data that we have, because it's not all, we find that it's hard to keep everything accurate across the whole terminal at all times, just because of the sheer scale. And then the next key sort of step in our process is the model production. So internally, prior to COVID, we had a full-time modeler, and we also used external resources to help with modeling. But it was largely a 3D model-based world or file-based world where, we had, as I said, 100 models, plus we've got a whole lot of other buildings, and they were all models themselves broken into disciplines. And so to manage that information is quite hectic with few people. So, going forward, it's separating that model or 3D model information with the database, and then having those two sort of linked and with a live connection, and then being able to feed that up to some sort of cloud-based viewer. And in our case, it might be that we have multiple viewers. So one could be within GIS, and one could be more of a building-specific one in the BIM world. And then going forward in the future, this helps us with connecting the data to other systems within the airport. So I'll show you shortly, we have a number of other systems around the airport, and having that structured open data that we can push to another hub or data hub, or a common taxonomy of what the airport calls certain assets, and then being able to feed that to the different system, because at the moment each different system calls things slightly different. So one might call a toilet, others might call it a WC, others might call it a toilet seat. So we need to understand what are those relationships. And in terms of feeding in quality building data, dRofus will play a big role in that, in getting structured, consistent data. So in terms of that's sort of the doing of it, but our strategy and sort of the high level thought of what we do is like our team. So I sit within what's called the spatial information team. So we're a combination of BIM and GIS, and primarily we've been GIS for the past 10 years, and now BIM's just coming into the process. So last year we did a bit of a strategy reset to figure out, okay, what are we trying to do? Because our team went from 9 people down to 2. So we had to really think, okay, how are we going to do this going forward? So first thing was to get our reason for being right, and what we do within the business is enable the business to capitalize on the digitalization of infrastructure assets throughout their full life cycle. So we're taking full life cycle approach, and our aim is to digitize the relevant airport assets so that the business can see. And our vision is to empower the wider business. So the reason for doing this is to empower the wider business with an accurate view of the past, present, and future of the airport's spatial environment. So people at the airport, they always want to be able to go back, see what was there in the past. They want to know what's there now, and they want to see what's coming in the future. So they're the 3 core drivers of what we do, is making sure that we can have that information available at people's fingertips, whether it be through BIM or GIS, and be able to then make decisions. And to do this, how do we get there in the short term, is that we want to collectively evolve the business's capability to collectively enrich the airport's physical and digital environments by seamlessly delivering high quality and trustworthy information for use in making valuable decisions. So the key here is that we're trying to represent the physical world in a digital way, and we want to deliver this seamlessly with high quality and trustworthy information, because when you have so much data, it's easy for data to not be trustworthy and of good quality. And at that point, people lose faith in the data and then stop relying on it to make decisions. And then they'll tell other people that, hey, the system's not correct. And then you build up this system of people not trusting the data. So our key driver from last year prior to COVID, or from the outcome of COVID, was to increase this quality and trustworthiness, because we found that it was sort of in places we were lacking because we were trying to capture too much information. So dRofus fits into this picture by helping us capture that high quality data and make sure it's help us make sure it's trustworthy within the building or terminal space at this stage. And then it enables people to actually get access to it, to be able to use it for decision making. And so the foundations of this strategy, we have 4 key things. And first is open data standards. We work with a whole range of projects and different companies, and not everyone uses the exact version of the same software at the same time for all projects. And so a lot of industry sort of talks that that's the way it should be, but in many ways it's impractical, and it adds a whole layer of cost and complexity to projects that doesn't need to exist. So having open data standards is key, because it enables different parts of the supply chain to use the best tool for the job and not force everyone to sort of use a Swiss Army knife of to do everything from design through to construction, fabrication, asset management, operations. To think that we can use one tool to do all that is not practical. And then tied to that is this idea of having flexible technology. So the ability to have technology that we can, replace one part of the tech stack and it doesn't make the whole system fall over. And also it means that we're not putting all of our eggs in one basket and reliant on one system, that if we do need to change for some reasons, that it means that the whole system falls over. So COVID is a good example of that, where, because of COVID, projects get stopped, budgets get cut, and if you're got a significant investment in one particular tool, then if that budget gets cut, then you've got to then completely rethink how you do things. Whereas with the open standards, effectively you can take away a lot of the systems, but you've still got your data at the end of the day, and then you can utilize some low-cost tools to actually still access it, and it gives us more resilience. The next key thing here is having strong partnerships. So that's both within the business and externally with companies like dRofus. We need to work together to be able to make this all work, because there's a lot of collaboration required. And the fourth thing is to actually build capability within the business and across the supply chain, because we all know that BIM isn't used widespread, and it still comes at quite a cost to projects and upfront. So we need to sort of make it business as usual, figure out ways how to get more people involved and upskill them. Teaching project managers how to use models for design review, or how to use clash detection tools or issue tracking, things like that, and tools like dRofus. And so, sort of built on those foundations, we then have 6 sort of key processes that our spatial information team go through that we're working to make sure that the data is actually good and can go out to the wider business. So, we define the standards and set the rules, but we don't tell people specifically what tools they have to use. It's more about the data structure. We're consolidating data all the time. We're pulling together models from various projects and capturing data in the field. We're going out to verify data in the field. We're then enriching it and adding information that hasn't been included during design and construction processes, or information that's only relevant to us as an asset owner. We're refining data, making sure that we have what's needed and not too much excess. And then once we have all that sorted, we can then connect the data to it's structured and clean, it's relevant, and we can then connect it to other airport systems such as financial registers or maintenance systems or operations dashboards. And this is something that we're still working on, so it's not all singing and dancing just yet. And why OpenBIM? For us, it's, as I said, it's about not dictating specifically what people have to use. It's more about the data structure and standards, and then allowing the supply chain to innovate and pick their best way to do it. So most companies have their own, Revit template or ArchiCAD template, and for us to have to always give out the template and then be responsible for maintaining that becomes a bottleneck in the process. Whereas if we give the data standards, companies can then set things up that still suits their way of working, but then still delivers our required outputs. So it's not about us saying you have to use this particular authoring tool. It's, okay, this is the data that we want, and then that enables the supply chain to actually try new tools if they want, and actually suggest other ways of operating. And actually, this is all communicated through what we call the Asset Information Delivery Manual. So it's a hefty 90-page document outlining our sort of requirements and processes. And the other thing to think about is this word common data environment is thrown around a lot, or CDE is thrown around a lot, and it sort of bugs me a little bit, because in reality, most CDEs only cover, if you look at our whole, a sort of high-level view of how an airport sort of ecosystem works, where we have, on the outside here, we have major projects and minor projects being delivered by various consultants, and then they have subcontractors and sub-consultants, all part of that, all feeding in, and you might have multiple consultants working on multiple projects at the same time. So typically the CDEs sit to solve this part of the problem, but at the end of the day, the airport's not in the game of architecture, engineering, and construction. So it's running an airport and basically a small city. So there's, at the end of the day, we're interested in the data that's coming out of the projects. And so if you look at this, see if I can make this make sense for you, but we have basically within the black ring, we have the airport common data environment, and then on the outside of that in the blue, we've sort of got what we like to call the security layer. And then within, you've got each segment as a different part of the business, and then each part of the business has its different use cases through here. And then each part of, they all might have their own databases for their whole operations, or just one task that's specific to their needs, whether it's like managing airfield lights, or building operations, or building maintenance, or staff training. So there's all these different systems, and at the end of the day, we just want to be able to get clean data about our built environment in to then be able to feed into these different systems. So the challenge that we have is, how do we do that as efficiently as possible and not have to duplicate information, because if we have to manually enter the same piece of data into multiple systems so that people can view it, then it's unsustainable and we can't keep up with that. So we need to be able to find a way to get data consistent and then be able to feed it around the business as needed. So I see it more as a common data ecosystem where our common data environment is actually the structured data that we're requiring and specifying in our asset information delivery manual, and it's a combination of tools rather than one particular tool that's been brought off the shelf, which is currently sort of, the likes we see with AIALs or BIM 360s or Procore. They're sort of more of a project tool, and even they, at a program level, it's hard to be able to see all the information across a whole entire program. So we need to see it more as a common data ecosystem and a system of systems. And our sort of current airport environment is that, we have at the top here external suppliers, so architects and engineers and consultants, contractors, and they're all working in their own, for each project can set up their own data environment. So whether it's a file server within their office, or it's BIM 360, or it's AIAL or Procore or BIM Cloud, or their own dRofus, it's whatever they use to deliver their project, they're free to do that, provided they then get the data back to our system. So the airport we provide, currently we don't have all of these in place, but we have a project document management system, and then now we're going to have dRofus, which we're just implementing. But the idea that dRofus will capture building design requirements and asset information, and then our project document management systems capturing the raw PDFs and native files and the IFC files, and then these are feeding further into our own auditing processes, and then to our storage systems, and then out to at the bottom here we have our different viewers. So there's sort of we have a lot of different tools for different purposes. We have to then audit that. We're also at the same time off to the side creating our own models using Autodesk and Graphisoft products, and then feeding that into a sort of all the different databases that it's needed, and then out to various views of the data. So we don't have all these in place, but these are just some examples of things that we could have for pushing out the data for different purposes. And a bit more on why we sort of dRofus. So the key thing here is that there's within the BIM world at the moment, there's this collaboration on files, and we're dealing at a file level, and those are typically dealt with in a capital project by the delivery team, and the client team is sitting in its own world where you've got a client delivery team who's representing the client, communicating with the delivery team who are external consultants, and typically they're just getting drops of files at a regular, monthly or 2 weekly basis to then review and feedback. But then on top of all that, this client delivery team is taking all the requirements of the end users to try and feed back. And there's a disconnect between what these people want and what they end up getting. There's often a disconnect between what they need and what they're getting, because there's just so many different requirements, so many different people across a business with specific requirements. How do you then make sure that they're all captured? And in the past, that's been, and still currently, it's done, with a lot of documents where we have these are just a few of the requirements documents, but you have document overload where you've got people from across the business with different standards and requirements that the teams need to read, over 1,000 pages, I think, if you go through all of our requirements documents, and then you've got, schedules of requirements and quantity takeoffs and room data sheets, and it's just information overload. And then at the end of it, you're getting schedules and asset lists, and just keeping track of all that across multiple projects across an existing building is chaotic. So the whole sort of idea of having dRofus that would sit across all the different project stages as a consistent database, and it can start at that space level, move on to design levels, construction models, as-built models, and then feed into operational systems. It's quite key to actually have that consistent platform that enables everyone to communicate. We can have the whole business, if someone has a specific requirement around putting Wi-Fi boxes in rooms, they can actually make note of that in the dRofus room data sheet system, and then that can then be fed directly to the designers once it's been approved. So having that ability to get sort of crowdsource, I like to say, is crowdsource the collection of the data and feed that requirement in a structured way in a central database is key. And being able to, then we can have multiple models, and it doesn't become too much of a burden. And the other reason for dRofus is that we want to know what we manage, so we're trying to capture our existing terminals, and then we also want to be able to use it to specify what we want in the future, because we have significant projects coming up with a lot of requirements. They're the biggest projects we've done in possibly ever. So it's at the same time helping us to understand what we currently have, but also making sure that what we build in the future, at the end of the project, we have we've got the design we want, we have the asset information we need, and we can then seamlessly push that through to our operational systems as needed. And that's something that we haven't really been able to do in the past easily, because it's required so much just manual checking, and there's a lot of different data all over the place. So it's really going to help consolidate that information. And so, the sort of key features are that dRofus gives us direct access to input requirements at an individual asset level. So it's not giving a whole list of requirements in a sheet to architects to then feed into a model that they then give back to us, and we've got to then trawl through the whole model to figure out if they've delivered what we need. And in many cases, a lot of what we need doesn't need to be modeled. So it's being able to manage all that information in a place and actually make the BIM process more beneficial. The other beauty is that we can access the data on web, on desktop, and on a mobile device. And then it's also reducing the need to double handle that information. And then a big one is the full audit trail, so we can understand what changes have been made, by who, and by when, and when. And just before I go into show a bit of a demo, one thing that I've noticed when implementing, or in the early stages of the implementation at the airport with any technology, and particularly with dRofus, is that an organizer is this law called Martech's law, which comes from the marketing technology industry, and Scott Brinker, who coined the phrase and this graph. But basically, organizations are changing at a logarithmic or a slow rate over time. The technology is going at an exponential rate, and you see this with BIM, where the AEC industry is racing off and getting into algorithmic design and artificial intelligence and talking about blockchain and automated clash detection and coordination, whereas these client organizations, they're not in that space, so they're moving much slower. They have other fish to fry. So they're not proactively looking to have all these things, because they don't necessarily benefit the business. They might help deliver a project faster, but in the big scheme of things, they don't help the sort of long-term operations of the building. So we need to understand that we've got to sort of plug that gap. And at the start of technology changes, you don't really notice the difference. But I think at the moment, BIM's got to the point where it's sort of accelerated faster than what most client organizations can keep up with, and it's because it's a model-based world. So you've got client organizations who are thinking they need to go out and hire tens of BIM technicians just to collate all their data and pull it together, and it's finding people that don't really exist in the world at the moment, and how do we pull these two curves together. So from my perspective, I think if we were to continue down the file-based path of managing multiple models within the business, we would effectively, it was unsustainable, because we would have had to hire too many people. We wouldn't have justified hiring enough people to keep up with the model, the data input, and then it just becomes just a complicated process. So we need other tools to get more people within the business to be able to contribute to that BIM process. So I see dRofus as the ability to plug that gap. And now we don't need, people can directly as I'll show shortly, change a piece of information in the model without actually needing to be in the BIM model themselves. So this will help close that gap a bit and sort of, reset the curve. So I'll just jump into a demo here of our domestic terminal and how it's connected to dRofus. So here we have a domestic terminal model. It's in ArchiCAD. And I'll show you I've got the floor plans. And so the thing with dRofus is we can change data either in the model and then feed it back to dRofus. Sorry, I've been a bit sick lately. Or we can change it in dRofus and feed it to the model. So here, just waiting for it to load, we'll have what we call a disclosure area. So this is the areas we need to report to what we charge the airlines for. So we can't charge them for certain spaces. So we want to understand what's retail, what's airport related, what's not related to the airlines. So here's a tenancy. McDonald's, if I go in here and change that information, it's then changing my graphic override in ArchiCAD, and it could do exactly the same thing in Revit. So that's the BIM modeler's view of it, but then anyone else in the business who doesn't know how to use the BIM software, they could come in and change this information in dRofus. So this I see is a huge step forward, because they can change that there in dRofus, and then if we need to then update any plans or outputs for anyone, we can then come back and sync that within the model and get the updated view that they want to be able to see if they need it beyond dRofus anyway. So the other thing we can do is then map, link data from dRofus to the model element itself. So we've got the dRofus web link, and then I'm going to show you quickly here how we then link that to the IFC model. So we've gone into the IFC mapping. We can then create an IFC property set. So we've got one called pset dRofus. And then we've mapped that link to the model, which is an IFC property, and then exported it. And then if we open that in Celebri, for example, the IFC, and then search for the space, McDonald's, and then go to the space, and we'll be able to then click on that property set and that property, and then navigate straight to dRofus web. Now, you could obviously just do this straight in dRofus, but why I want to show this is because we can now, with GIS, we can take IFCs to GIS. So we could effectively upload the IFC model to GIS, and then it would enable people within GIS to then click on a space. That link would be there available in the properties, and then they could take them to dRofus. So it's just improving that end user experience, that when we have the IFC model, we can put it to different places. People can click on it and they can get taken directly to dRofus. They don't need to then log in, open dRofus themselves, find the space they're looking for. They'll be able to navigate straight from that model experience. So this idea that people can change the data, on the desktop, on their phone, means that we can then get the people at the source who know the data to change it themselves, rather than having to feed the data back to our team. And then the other beauty of that is that a lot of people in business want to know where particular assets are. So say like a Wi-Fi box, or even the equipment that's in an office space. So they'll be able to manage that data themselves, which if they didn't have a tool like dRofus, they would rely on our team, and we wouldn't have the resources to do it. So it would never get done. So it enables different use cases because it just simplifies the process. So this is things that we haven't yet fully implemented, but we'll be able to do it going forward. And then the dRofus web enables people to have an accurate view of the terminal, and be able to then filter the data that they want. So here they can find all the restrooms, and then find certain objects, what's in a restroom, find information about products, and basically just interrogate the building data to a point where they haven't been able to do in the past. So just jump forward here. This is just you're looking for products where they can start to get product information, and you can all find this stuff on the dRofus website, I guess, how to do it. So yeah, and then another example of using dRofus recently is that we've got our GIS plans and we want to get to the point where we use the BIM models to provide the floor plans for GIS, and so then the BIM models become the most up-to-date version of the buildings, and dRofus is just a view of that data. But at the moment we need to audit what's in GIS and what we have represented in the models and then find discrepancies. So here I've gone through checking the GIS plans against dRofus and seeing where there's discrepancies, and if there's a difference, I've just made a note within the web viewer and included GIS somewhere within the note. And then in dRofus I can go to the properties panel or the table and then filter the note section and just say anything containing GIS, and then I can now see all the spaces where I've gone through and noted where there's something about the naming's wrong, or there's something, the space isn't exactly the same. And then we can quickly see all those spaces in the model where there's something that needs to be checked, either by asking someone or going out on site and having a look for ourselves. So it just simplifies that whole process, and it means you don't need to be deep in the models to be able to make use of them. So yeah, that's all from me. I'm happy to take any questions.